Okay, so this is section 3.5, justifying conclusions. So the first thing we're going to do here is we're going to look at the definition of proofs on page 139. So if you look on 139 for definition of proofs, it says a proof of a conditional, so conditional is an if-then statement. So a proof of an if-then statement is a sequence of justified conclusions starting with the antecedent, so the if part, and ending with the consequent, the then part. So we've got an if-then statement. Sometimes they'll call it like the given and what we're trying to prove, so that's similar to the if-then. And basically we have to justify with theorems and postulates and definitions how we got from one step to the next. Okay? So looking at this first one here, example 1 says that we're given the equation 5x minus 17 is equal to 32, and we're trying to prove that x is equal to 8. Okay, so when we set these up here, the first thing that we're going to put on our conclusion side is always what we're given. So here we've got our given is the 5x minus 17 is equal to 23. So we're going to put that here, so 5x minus 17 is equal to 23. And then in the end, our goal is to get to the point where we get the answer, x is equal to 8. So the last thing on our conclusion side is what we're trying to prove, which is going to be x equals 8. Okay, so similar to the last lesson, this first thing for our justification, since they gave it to us in the problem, our justification for that is just given, because it was given to us, and then we've got to fill in the stuff from here. Okay, so when I'm going to solve this equation, the first thing I'm going to do is I'm going to get rid of subtracting 17. So I'm going to add 17 to both sides, because then that's going to go away, and I'm going to be left with 5x is equal to, and then if I do 23 plus 17, that would be 40. Okay, so now for my justification for this, I want to figure out how I went from the first step to the second step. Okay, well if I look here, what I did was I added 17 to both sides. So adding 17 to both sides, adding the same thing to both sides of an equation, is our addition property. So this is addition property of, and then it's an equal sign there, so addition property of equality. Okay, now our next step here, we've got a 5 in front of the x, so that means multiply. So to get rid of multiplying, we're going to divide. So we're going to divide by 5 on each side. And then when we do that, we get to our answer that would be 8, because 5 divided by 5 is 1, so just the x, and then 40 divided by 5 is the 8. So we do get that answer of x equals 8. Okay. Now the important thing isn't getting to that answer, the important thing is showing how we got from step to step. So from the second step to the third step, we divided each side by 5, which we don't have a division property, but we do have a multiplication property. So if we multiply by the reciprocal, which would be 1/5, that's the same thing as dividing by 5. So here we're going to use multiplication property of equality. Okay, so if we're adding the same thing to both sides or subtracting the same thing from both sides, that's the addition property of equality. If we are multiplying or dividing the same thing on both sides, that's multiplication property of equality. Okay, and that's all you would have to do for that one. So now we'll go to the next one here. So this one's slightly different. This one we've got a picture. So it says given a circle y, so that would be our circle here with the center y, and has the points x and z on it, so we got x and z, we're supposed to prove that the distance from x to y is equal to the distance from y to z. So we're basically proving that those two distances are the same. Okay, so like I said before, we always start with what we're given. So our given here is a circle y, has the points x and z on it. So we'll just write that full statement in there. So circle y has points x and z on it. Okay, and our justification for that is, well, we were given it was in the problem, so given. Okay, Now the next one here is the last one we're going to do. So the last one on the conclusion side is always what we're trying to prove. So this is going to be xy, that distance, is equal to the distance from y to z. Now we've got to come up with our reasoning to get from the first step to the second step. So for this one, it's actually a definition here, and it's back in chapter 2, so one of the definitions we had in chapter 2. And some hints I would kind of think here is I would be looking for either definitions, theorems, or postulates that are dealing with circles, because we have a circle here. Okay, so when I'm looking through my list of them, I would look for things that hint on circle. Okay, so this is actually going to be from section 2.4, and it's going to be definition of a circle. So definition of circle. Because that definition basically says a circle is a set of points in a plane at a given distance from a given point. So what that definition of the circle means is we've got some point, and then we've got a whole bunch of other points, all the same exact distance away. So that's kind of showing there that those points, so like say some point there and some point there, those are all the same distance away, or like a radius. So that goes with definition of circle. Okay, and that's basically the same exact setup as we had before. Okay, so like I said, if it has a circle in it, when you're looking through your list of theorems, postulates, and definitions, I would look for something that involves a circle. Okay? Okay, next thing here. So proofs outside of math. So proofs aren't just limited to math. We do them in math to prove mathematical type things, but there's also other professions that they use things that are similar to proofs. Now they might not call them proofs, but they're kind of the same thing, where they've got a problem, and then they go step by step to figure out what the solution is, and they have to back up what they're doing for each step with like a law or something like that. Okay, so an example here is lawyers proving without a reasonable doubt that someone has committed a crime. Okay, so lawyers proving that someone did something would be like a proof. Okay, because they're gonna back it with evidence, they're gonna back it with fingerprints, they're gonna back it with a video or eyewitness statements, something like that. That's them justifying each one of those conclusions. Okay, so that's where you would see proofs outside of math. Okay, the next one here, example 3. We are given that the measure of angle 1 plus the measure of angle 2 is 90 degrees. So these two angles together are going to make 90 degrees. And then the measure of angle 2 and the measure of angle 3 is also 90 degrees. So 2 and 3 added together is also 90. And we're supposed to prove that the measure of angle 1 is equal to the measure of angle 3. Okay, so let's fill in the information we know to start. So we'll start with our given here. So our given would be the measure of angle 1 plus the measure of angle 2 is equal to 90. And the measure of angle 2 plus the measure of angle 3 is equal to 90. Okay, and then that is our given because that's what we started out with. So our justification there is given. And then the other thing we know is our proof. What we're trying to show here is our last step on our conclusion side. So we're trying to prove the measure of angle 1 is equal to the measure of angle 3. Okay, so let's walk through this here. So to get from the first step to the second step, basically what's happening is they're changing. So they've got, let's highlight this here. So we've got measure of angle 2 plus a measure of angle 1 plus a measure of angle 2 is equal to 90. So that there. And then we've got measure of angle 2 plus a measure of angle 3 is equal to 90. So that there. Well, they actually have those same exact phrases down here. So measure of angle 1 plus measure of angle 2 is the same there. And then 2 and 3 is here. So basically what they're doing there is they're saying since both of those two equal 90, then they have to equal each other. Okay, so what this is this is the substitution property. Okay, so we'll put substitution property here. And the substitution property is basically when we replace something. So we knew both of those were equaling 90, so we replaced the 90 with the other one. Okay, so with the other group of angles. So we took one of the group of angles equals 90, and then we know, since this one equals 90, we can replace the 90 with that other set of angles. Okay, that's how we get to this here. So then to now how to go from the second step to the third step, the only thing that changes here is this one's measure of angle 1 and 2, this one's 2 and 3, and then it's just 1 and 2, so basically we're losing the measure of angle 2 from each of those, or since it's kind of like an equation, you can think about it as like subtracting those angles off. So if we think about it as subtracting the measure of angle 2 off of both of those, that would go away, that would go away, so we'd be left with measure of angle 1 and measure of angle 3. Okay, so if we're subtracting the same thing from both sides, well, we don't have a subtraction property, but we do have an addition property, which is the same as adding a negative. So this is going to be addition property of, and then it's equal, so of equality. So even though we're not just adding or subtracting numbers, we're doing it with angles, that's still fine. That's still the addition property of equality. Okay, so the last thing here, you're thinking, okay, why the heck are we even doing this? Why are we doing proofs? So the reason the book gives for why we have to do this is a proof establishes, without question, the truth of a statement from the postulates and definitions in the system. So basically, we are just proving for a fact that these are coming out, the answers we get are coming out how they should based on mathematics, okay? I know they're kind of long and they're kind of difficult. The more you practice, the easier these get. A lot of the examples are actually really similar to this. So like if you have an equation problem, like this first one here, a lot of times these are all really similar where they're either going to use the addition property or the multiplication property. Like I said, if it's got something with a circle in it or if they say something about midpoint, you want to use those as clues when you're solving these out so you can kind of narrow down your list a little bit so it's not so overwhelming when you're trying to figure out which one is which. Okay, so that is it for our notes. So you guys have the book page 142, 2 to 26 even, and then also number 7. And let me look at those to see if there's any that you need help setting up. So it looks like there that 7 is going to be a proof 1, but you're just filling in the blanks, so you're looking at that information there, filling in those blanks. It looks like 16 is also a proof 1. But again, you're just filling in those blanks, so they give you a lot of the stuff, and you're just coming up with the justifications for those.